Welcome to the lab. So today we're going to be measuring total dissolved carbon dioxide in seawater, and we're going to be approximating that by a measure of alkalinity. So we're looking at the carbonate system, which, remember, when CO2 dissolves into seawater, it forms three different chemical species. So you have your fully protonated form is carbonic acid. You have the form that just has one hydrogen ion, which is bicarbonate, and then the form that has no hydrogen ions, which is carbonate. So we are going to be measuring the combination of these three forms today in a titration. And what we're doing is we're going to be adding acid to seawater samples, and that's going to be changing the acidity of the seawater and shifting all of those species over to carbonic acid. So the way we quantify these is by measuring how much acid we have to add to our seawater sample to get all of the dissolved carbon into the carbonic acid form. So functionally today we're going to be doing a titration, and as always, to understand something in our unknown or in our sample, which is what we have set up over here, we have to compare that to a known sample. So this is our standard over here. So we're going to be doing two titrations. If you're doing this by yourself in the lab or with your group, usually you would run these sequentially, but we can run them in parallel here, so you can just, it's the same setup for both of those. So we're going to just get our standard and our sample prepared, and then run these two titrations in parallel. So the first thing is, as we're doing this titration, you need to know how much seawater you have in each vial. So we're going to measure it using a graduated cylinder. We're going to put a 50 milliliter sample for both our seawater and our standard in here. But we want to be really accurate with this volume, and graduated cylinders only have mediocre accuracy. So we're going to weigh our sample as a more accurate way to measure that volume. So we're going to start with our standard, and what we use for the standard in this experiment is sodium carbonate. So this has a known amount of those dissolved carbon species that we described. We are working with 0.003 molar carbonate. So we're going to measure in a graduated cylinder 50 milliliters, but we're going to weigh exactly how much that is. So we're going to start by putting our beaker on a balance here. We're going to tare the balance, so we'll just set it to 0, and then we'll add our water and record the weight of the volume that we add. So we're going to tare this. It's reading 0. Okay, we'll take our beaker over here, and we're going to pour in 50 milliliters of our standard. So again, this is our 0.003 molar sodium carbonate. All right. So we've got 50 milliliters of our standard. We'll pour that in our labeled standard beaker. Bring that back over to our balance, and we'll record that weight as our very accurate measure of how much standard we're measuring here. So 49.65 grams. All right, that one is ready to go. Then we're going to do the same thing for our seawater sample. The sample that we're going to be measuring today is seawater that was collected at Rasmus Beach. We collected off the dock there, so we often call this dock water. So this is coastal seawater, and we'll be measuring the total dissolved CO2 in this coastal seawater. So we're going to get our 50 milliliter sample. So we have our 50 milliliter seawater sample. We're going to put our beaker on here, and we're going to tare the scale to set it at 0. And then use the mass that we add here as our accurate measure for the volume. So we've got our beaker. I'm going to pick that up to pour our 50 milliliters of seawater sample in and measure the volume there. So 50.55 grams is the mass for our seawater sample. We're going to use these stir plates so that each time we add acid in our titration, we're going to be mixing that thoroughly through our sample. So we have the way we're going to be measuring the The titration is that as we add acid, we're measuring how much free proton is still in our sample here. So the carbonate species are going to be consuming the protons or the acid that we're adding until there's no dissolved carbonate left to consume those protons. So we're going to be measuring that change, the addition of those protons and the consumption by the CO2 using conductivity. So this is going to be our data for this lab. We just need to know how much acid did we add. We're going to use a pipette to measure that. And then we just need to record the conductivity measure here. So again, we've got our sample set up here and our standard set up here. And they've just been equilibrating. You want to keep these probes nice and wet all the time. So we've just had them waiting in some seawater until we're ready to go. So I'm going to lift this out and take off our equilibration beaker here. Lift that out. Okay, and then I'm going to rinse these before we drop them into our samples. So we've got some nice clean deionized water here for cleaning those probes. Rinse both of those. All right. Now we're ready to put our sample over here and our standard over here. So these are magnetic stir plates. We're going to drop in our magnetic stir bars to be able to mix our sample and get that acid addition fully mixed in. So we'll just carefully drop that into our sample. And we've got our stir plate on. And we have it at sort of a medium speed. We want it to be mixing thoroughly but not too fast. If we sped it up, you could get a really strong vortex going, which is good mixing, but is not going to be great for the pH probe in there. So we're going to have it at sort of a medium speed, mixing well but without a vortex. And then we'll just adjust this to find the quiet spot. And then we're ready to carefully lower in our pH probe so that the tip is fully submerged but not running into that magnetic stir bar. So we should be good right there. Our probes are submerged, and because these are different samples to start with, you're going to see that the conductivity measure here is different on these. So the values that we're recording in, this is conductivity in millivolts. So this is what you're recording as your, quote, EMF value, and the units are millivolts. This is what we'll be recording as we go. They start out negative in both cases. We're going to give this just a minute to equilibrate in these new samples here, and then we're going to start adding our titrant. So while we wait for those to equilibrate, I'm going to get our scale out of the way. And this is one lab where, rather than recording in your lab notebook, we do recommend that you record directly onto an Excel file. So ideally, I would have a scribe here with me who would type as we go, so I'm not typing in gloves. So we're going to record the values as we go because your Excel template is set up with a graph that's going to plot these values as you go, and you're going to be able to see the titration points as you go here. And that's really, you kind of need that visual indicator for knowing when you're done. So, so we're going to plot these as we go. So the first thing that we want to do is wait for these to look like they've pretty much stabilized, which that's looking good. So we're going to record those initial values. And I love redundancy, so I've got a lab notebook and my laptop. So our standard, the initial conductivity is negative 124.2. And our sample is negative 70.9. And then one nice check, these meters measure pH as well, so we can just change the mode. This gives us a good sense of what are these samples that we're starting with. And the pH is a good indicator for when you're done with this titration. Again, we're adding acid, and so we're going to be decreasing the pH, so dropping in number. And the titrations, you know you're getting close to the end when you get to a pH of about 3. So we can check back in on that pH throughout the experiments to see how close we are to done. So I'll just write that down on the side just for reference. It's not something we're going to calculate with, but our sample is starting out at a pH of 8.200. And our standard is starting out at a pH of 9.089. All right, so I'm going to switch us back over to the conductivity mode, and that's what we're going to be reading throughout the rest of these experiments. So our titration, we're just going to be adding known volumes of acid, and measuring the conductivity. And we're going to do that for many acid additions so that we're going to, in the end, see this calibration curve or a titration curve and see the consumption of one of those carbonate species and then the consumption of the second species. So we're going to set our pipette to 50 microliters, and we're going to use that then throughout our experiments. So we're going to add 50 microliters of acid to our standard and 50 microliters of acid to our sample. And for this first addition, you want to give it a little bit longer to equilibrate. So in the lab manual, it says 3 minutes. So you'll see now, after we've added that acid, our conductivity measures are changing pretty rapidly. So we're going to give it a little bit of time to equilibrate there, and then we'll measure the conductivity after 3 minutes here. The acid that we're adding is 0.25 molar hydrochloric acid, and then we've also added salt, so it has the same ionic strength roughly as seawater. So it's hydrochloric acid with 0.7 molar sodium chloride. So basically salt, to make it a similar salinity to our seawater. All right. 3 minutes later, our samples have equilibrated at this point. So this is our first conductivity measure that we're going to record for each of these. So for our sample, we have a conductivity of negative 43.3, and for our standard, we have negative 102.8. Sorry, 102.8. All right. So I'm writing these down, and we're going to enter those in our spreadsheet because we'll be able to see that curve start changing as we go here. So from here on out, we're just going to add another aliquot of acid to our standard and an aliquot of acid to our sample. And then we recommend waiting a minute in between. You can see the numbers rapidly changing right now on each of those conductivity meters. And after about 45 seconds, really, they'll stabilize. So waiting a minute is safe to make sure that you're reading a consistently stable amount. It's helpful to have a timer as you go for this. So you can literally, add that, set yourself a 1 minute timer, and then just wait as you go to have that stabilize. So at this point, they've stabilized on each of those, and we would just record these conductivity measures as we go. And we're going to be doing about 20 to 30 additions of acid to each of these to get that full titration curve. So you'll record as you go, and again, we could check in on the pH as we go to see when we're getting close to that endpoint. All right, so I've been writing down the volume of acid that we've added and the conductivity reading off the meter for our standard and our sample. And for that initial time point, we recorded the pH for each of them. So your Excel spreadsheet is set up to record these values. So you have a tab for your standard and a tab for your sample. This is your volume of acid added and that conductivity reading. So as we enter in the data here, so we're doing a 0.505 milliliter addition each time, or 50 microliters. As you enter in our data here, you're going to see the points appearing on your plot, and this is what is going to show you that titration curve as we go. So that visual is helpful for knowing where you're at in the titration process. Once you've accumulated 20 to 30 data points, this is what your curve is going to look like. So again, this is your volume of acid added versus your conductivity reading, and you're going to see that first inflection point, the consumption of your carbonate, and then your second inflection point up here, the consumption of the bicarbonate. And then when you're fully equilibrated and the points flatten out here, everything is in the form of carbonic acid down at a low pH. So that's what we're going for in the end, is a titration curve that looks like this for your sample and your standard. All right, so now we've done almost 20 acid additions into each of our sample and our standard. So you can see the conductivity is much higher now on each of these. So you guys will have all of the data points along the way for each of those additions. So this would be a good time to check how we're doing on the pH for each of these. So if we switch over to pH, we can see that the pH for our sample is about 3. So that tells us that we're close to that endpoint. And then you want to do 3 to 5 acid additions where the conductivity hasn't really changed. That's where you're leveling off at the top of that equilibration curve, titration curve. And you need a couple of data points there at that stable point to make part of your calculations. So we're going to do about 3 more acid additions on this one. And for our standard over here, it started at a different pH. And so that you can see the conductivity is still lower. The pH is about 6. So we have a good number more acid additions that we'll keep doing over here to get through that second inflection point on the titration curve and up to the stable point in the equilibration. So you'll see all of that data in the spreadsheets of those continued acid additions for the standard and getting those full titration curves. So in the end, you're going to have a lot of conductivity and volume of acid added data. And then in class, we're going to walk through the calculations for how you interpret those curves and turn that into your calculations for the different components of that carbonate system.